Hi, this is Tim. Today I want to talk to my technicians about predictive maintenance and one, why you should not feel threatened by it, and how, if properly used, this could really improve our job roles. Now, I said properly used. I don't believe anything out on the market is really doing a great job right now. So, first of all, let's talk about the two big types of maintenance that I think this, if we could smooth this over, I think if we get everybody talking, this could be a really cool opportunity. Is what predictive maintenance is claiming is that it's the new way. No, I shouldn't say predictive maintenance. A lot of y'all are doing a good job, but I just read one and then I was Googling and this is kind of the repeating pattern I'm seeing is a lot of the predictive maintenance modeling softwares are saying that they're the new way, and that reactive maintenance, that's the old way. We're not going to use that anymore. Now, first of all, reactive maintenance, let's talk about what that is. That is the machine is down, and we need to think incredibly fast about the problem and resolve it to get it back running. That is our most expensive downtime. Now, I don't feel that we can ever eliminate it, but hopefully we can minimize it more. Now, still, you need the smartest people probably in the plant on those reactive maintenance calls. And when y'all put out there in your ad that reactive maintenance is the old way, it's going by the wayside. Well, yes, you just threatened a lot of people. And here's the thing, those people that you're saying are obsolete, probably ones y'all need to be talking to right now. So let's just go through a reactive versus predictive, scenario and see where we should be able to get to. So in reactive maintenance, let's say we got a gearbox, it's a noisy plant, so you can't really hear a lot. That gearbox blows up. Well, the machine is down now. We have to change the gearbox out. And really the technician's skill is how fast can they change that gearbox out? And that is an important skill. What predictive maintenance promises is that we should be able to use probably vibration monitoring and sense that bearing is going bad. And then, that same technician, because that technician, if he can change a gearbox out, chances are he can verify that, that bearing is going bad. It is still running, but we need to get this gearbox changed out. So at that point, we have taken an unplanned downtime. There was a gearbox blowing up, and we've turned it into a planned downtime. Now, that is huge when it comes to cost savings, because unplanned downtime obviously is the most expensive downtime because it wasn't planned. But I'm also surprised that I probably should do a video how you calculate it. I'm surprised how many companies don't really know just how expensive unplanned downtime is. So from our technician's perspective, we need to start getting to where, we understand how these vibration sensors or, she's as an example, these smart sensors connect to our PLCs or connect to the cloud so that we can start interpreting their data. And, here's where I know AI makes a lot of promises of being able to model, and I do believe it'll get there. Today, still, that technician is the one who has the most knowledge, and they're the ones that really need to be helping us figure out how to set these up so that we can actually trigger something and that we don't get 100 triggers that a bearing is going bad when it doesn't, because false data will cause more grief than no data. So really, obviously the training center, this side right here is set up for that reactive maintenance, which is still the most expensive maintenance there is. It's the one that we need the most people qualified on. In a few short months on this side of our training center, we are going to have a class with a lot of discussions over predictive maintenance. In other words, okay, now we know what it looks like when this component goes bad. We know what it looks like when this machine goes bad. What can we add to our systems, or what can we leverage that we already know? So we have a robot here. It's got 4 motors on it. We have current sensing on all the motors. And you probably do too, and you're not doing anything with those. So how can we get our known good baselines and then start alarming when it goes a little bit above or below our baseline? So there'll be a link down in the description. where you can learn more about that class, and I'll see you then.